Hello everyone. This is our second lecture on the course Strength of Materials. So already in lecture 1 we have seen the basic concepts of strain energy and also the strain energy due to gradual loading. In this video we are going to see about the strain energy due to suddenly applied load as well as the strain energy stored due to impact loading. We'll see one by one. The first one, here is the difference between the suddenly applied loading and the impact loading. In the previous lecture itself, I have discussed what is the difference between suddenly applied load and impact load. Again, we'll see the difference between those two. In suddenly applied load, the load will be applied instantaneously, but without any initial velocity, and then it remains constant. This is the diagram to explain about sudden loading. But in the case of impact loading, a moving or a falling load will be striking the member with some velocity. So that is a major difference between suddenly applied loading and impact loading. In suddenly applied loading, it remains constant. That is, there is no initial velocity, and here the velocity, it will have some velocity. That is a load which is falling through some height. So there is a difference between the two types of loading. And here is the stress which is developed due to suddenly applied loading. We have already seen in case of gradual stress, that is gradually applied loading, stress will be load by area. But in case of suddenly applied loading, the stress will be 2 times of P by A. That is, suddenly applied loading, the stress in suddenly applied loading will be 2 times that of the stress in case of gradually applied loading. And the strain energy will be half P into delta. In case of impact loading, the strain energy, we have already seen the work done will be equal to the work which is stored. So just you can see this formula, and this will be explained in the further slides. The key feature in case of sudden loading is that, as we have seen in the previous slide, there is no impact velocity, but there will be dynamic amplification, and the stress will be 2 times that of the gradually applied stress. And here is, in case of impact loading, the key feature is that kinetic energy will be present and the stresses will be much higher than in sudden loading. Here is the major difference in all these aspects between suddenly applied loading and impact loading. So already we have discussed this. Here a concise and precise difference is given between the two in the aspects which is listed here. First we'll move on to the strain energy due to sudden loading. In case of suddenly applied loading, the load is applied suddenly. The load will be P throughout the deformation. In the previous slide we have seen, and the load will be constant after applying, thereafter it will be constant. But the resistance will always increase from 0 to R. And this is the load deformation diagram, and this is the resistance deformation diagram. The work done on the bar will be based on this one, and this work stored will be based on this diagram. First one, work done on the bar will be load into deformation. So which is marked as equation number 1. And then work stored in the bar will be based on the second diagram which I have shown in the previous slide. So that will be half into R into delta L. Since it is a triangular pattern, it is half into R into delta L, and the load deformation pattern was a rectangular pattern, so that was P into delta L. That is the area. And here it is half R into delta L. So R will be stress into area. And as we know, work done will always be equal to work stored Work done is P into delta L, and work stored is half sigma into A into delta L. And from here, so if we take P will be half into, both delta L will get cancelled. So it will be half into sigma into A. And when we take stress sigma to the other side, it will be 2 times of P by A. Hence, and the stress in case of suddenly applied load will be twice the stress in the case of gradually applied load. So this is our conclusion from all these equations. Okay. And next, we'll move on to the next one. Strain energy due to impact loading. We have already discussed that impact loading is a load which is dropped from certain height h. So here we are taking it as h. And you can see here the load is applied from a distance of h. As we already know, work done will be equal to force into deformation. In case of previous thing, we have written P into delta L. But here the deformation is, the load is dropped from a height h. So the deformation will be h plus delta L. Okay, so what is this delta L? So this delta L is change in length, and we have derived it from the Young's modulus formula. So we already know that is Young's modulus is equal to stress by strain. So what is strain? Strain will be change in length, that is strain will be equal to change in length by original length. So from this we have derived for delta L, which is sigma into L by E. Okay. Then work stored in the bar is, it is a triangular pattern, so half into R into delta L. Okay. The strain energy, this we have already derived from the first one. There is a first derivation which is due to gradual loading. We have derived this for strain energy, that is strain energy U is equal to sigma square by 2E into V. So we are taking that equation directly. The work done is P into H plus delta L, this one, which is equal to the work stored, which is the strain energy which is stored, that is sigma square by 2E into V. And instead of delta L, substituted here, instead of V, we have substituted area into length. And then multiplying P with the two terms, you will get this. And then on both the sides, we are multiplying by 2E by L, that is on both on the left as well as on the right side. Then multiplying by 2E by L, we'll get this one, we'll get this quadratic equation in terms of sigma. Then we need to solve this equation, so you have to find out the roots for this quadratic equation. So the general formula what we use to find out the quadratic equation is minus b plus or minus root of d square minus 4ac by 2a. So using that, we are going to find out the roots for this particular quadratic equation. Then if you simplify that, and if you find that this will be the root sigma will be equal to p by a plus, if we take, see here you have p square by a square. So when we take it out of the root, it will be p by a into root of 1 plus 2aeh by pl. And this is the expression for stress due to impact loading. Since it is impact loading, stress due to impact loading, it is denoted by sigma I. And here in both terms, P by A is common, so you can take it outside. So it will be 1 plus root of 1 plus 2aeh by PL. Then this P by A is already known as stress. So instead of P by A, we can write it as sigma. And delta L, we already know this formula for delta L, which is PL by AE. From here, take sigma to the other side. So sigma I by sigma will be equal to n. That is, we are taking this term to be n. And this term, we are taking, this term is called as the impact factor, which is denoted by N dash, which is root of 1 plus 2h by delta L. From the equation here, sigma minus P by A equal to root of, from this equation, what is derived in the previous steps. If we take P by A to the other side, it will be this equation, will be getting this equation. If this is in case of impact loading, if H is equal to 0, what will happen? The impact load will be changed into suddenly applied load, because only the impact load we have some height, that is height of fall. In case of suddenly applied loading, so if we take H is equal to 0, this impact loading will be changed to suddenly applied load. Substitute H is equal to 0 here, this term will be 0. We'll be getting P by A plus root of P square by A square plus 0. And when we take P by A out of the root, it will be P square by A square. When you take out of the root, it will be P by A. Obviously, we get 2P by A, which is the stress for suddenly applied loading. When the delta L, that is a deformation, is when it is very small compared to H, we can, when it is very negligible, we can neglect that. So the work done will be, previously what we have written for work done, P into H plus delta L. So when delta L is very small, you can ignore that, and this work done becomes P into H. What happens here? This is the strain energy U, which is sigma square by 2E into V. So instead of V, it is written as A into L, here P into H. And sigma square will be, take all the terms other than sigma square to the other side. It will be 2E PH by AL, and sigma will be root of 2E PH by AL. This is the stress for impact loading. And thank you.